Hello, my name is Nicholas Hempenius, and today I will be talking about blockchain technologies and cybersecurity. So, a quick overview. I'll want to get into sort of the background of blockchain and most typical uses, blockchain and the CIA triad, and I'll also going to get into actual security applications of blockchain in areas like intrusion detection and prevention, data storage, and access security and IoT security. So, a little history. Blockchain was first seen in a white paper by uh, Satoshi Nakamoto, um, and the white paper was called Bitcoin, a peer-to-peer electronic cash system. It was mostly directed at solving existing financial market challenges. Um, I believe the primary focus was to defeat the double spending issues commonly found with electronic cash systems. And although blockchain was never directly referenced in this paper, the words blockchain can be found kind of throughout the developer comments in Bitcoin's code. So blockchain is basically a decentralized chronological record or ledger that is sort of made secure and immutable through Merkle hash methods, where you can see in this image right here, each record or each block of transactions is connected to the previous one through a block hash. So sort of how blockchain works, there's kind of like a five-step method. Initially, first step, the block is, or the transaction is prepared. This is going to contain information like the source and receiver. It'll also have the message in it, stuff like timestamps and other cryptological information. Um, Then that transaction is made available to all the nodes on the network, and they will begin verifying that transaction. And as transactions are posted onto the network to be verified, uh, they will be placed onto the blockchain queue, and they'll sit there until all the other nodes on the network verify that transaction. So that's when one node will begin to collect transactions on the blockchain queue and attempt to create a block. Um, so when a block is generated, it will also require to be validated there in step 4 by the other nodes in the network. And when it has been validated, um, it posted onto the ledger. The ledger will also be validated, and then that means um, once the ledger has been validated and all the nodes come to a consensus that that block on that ledger is the authority, then the block is chained and the entire process kind of starts over again. So some the more typical applications that we all hear about are blockchains being used as like a way to uh, watch audit trails, most typically in cryptocurrencies and smart contracts. Smart contracts are sort of like um, a blockchain that is recording uh, business dealings between two parties, and usually those business dealings are also programmed into the smart contract. So the smart contract would literally be code that ensures that two parties adhere to something they've agreed on. So here is the CIA triad, and I'm going to talk about a little bit about how blockchain addresses confidentiality, integrity, and availability. So, using encryption, you can actually encrypt the message within the blockchain and also use attribute-based access control only allow those who should see the messages within the individual blocks and the transactions within those blocks to limit who can see what's inside the actual transactions. And although it's common for stuff like Bitcoin and some of the cryptocurrencies to not use the actual encryption of the message itself, it's becoming more and more common for other implementations of blockchain too. A distributed ledger with Merkle tree hashing allows for addressing integrity in a blockchain, and because blockchains are normally decentralized and spread amongst multiple nodes, and all the nodes are holding the ledger, there's no single point of failure. So security blockchain applications, the three I will be talking about today are intrusion detection, intrusion prevention, and CM security auditing style systems. One, for example, is the Norris security ecosystem. We're also going to talk about secure data and secure access management through a blockchain-based medical storage system and a blockchain based IoT security system. So blockchain and intrusion detection and intrusion prevention. The Norris security ecosystem is sort of like a massive IDS, IPS. It's meant to span multiple countries to allow for the largest amount of consensus. You can see kind of in that image, each company would sort of have a branch of the master chain, and these branches would be like somewhat like an internal anomaly-based IDS, and to address a lot of those issues that come with anomaly-based, like manipulation of the baseline, each new machine that would be put onto the chain would have to go through a learning timer where it can only use known good software and only be used for known good applications. And each machine or each device that's attached to the chain would have what's called a smart proof of existence. It's basically a hash ID of that device. And this is currently being used out in Dubai by a company named Prow, an IT solutions company, and it's proving to be successful in detecting attacks very quickly, claim within seconds, and inoculating virtually all of Dubai that's attached to Prow IT solutions of attacks against companies. So here's a blockchain kind of framework for secure storage of medical records. In this, the blockchain just stores sort of like a record index of your medical information, and then there's a cloud service that would store your actual medical records. And so the cloud service itself would not have any way of seeing the information because it would all be encrypted and the access control would be handled by the blockchain. So this allows for patients to have a lot more control over their records, and in real time patients can go in and manipulate that access control. So it sort of works in a three-step process. Medical data is released by the practitioner, or say your doctor. So your doctor would create the medical record. He would sign it with his private key, encrypt the medical record in the private key, and send that up to the cloud in the blockchain. And then that information would only be able to be read by you as the patient, and you would have to allow for other service providers to also read that data. So kind of in that three-step process, it allows for a much greater increased freedom of patients to have control of their medical records, and it's better for the providers as well because they don't have to wait on um, uh, patients to fill out forms and the bureaucracy of current medical record management systems. So, blockchain in the IoT sphere, uh, one one system that has been built is the IoT chain. It has sort of a three-layered approach, and you can see in the image right there, uh, there's a certification layer, an application layer, and a blockchain layer. So the certification layer would have the certification center and the detection center. The certification center would handle um, things such as uh, certifying new devices that are attached to the blockchain and certifying manufacturers that attach and service providers. In the application layer, that would be where the regional nodes are. Those can be kind of seen as like the miners for the blockchain. Regional nodes sort of handle some of the heavy lifting in the blockchain. The blockchain also resides on the nodes, and as devices connect, regional nodes would handle information between those devices and their manufacturers and service providers. Regional nodes hold registry tables, so each device connected to the network needs to be registered. An update table, which is a table that records what devices are up to date. So this framework is mostly focused on allowing secure updates to your IoT devices and keeping those devices updated. It also has a permissions table, so who's allowed. The permission table addresses sort of who's allowed to connect to those devices. So, for example, your refrigerator, the only person that should connect to your refrigerator is you and the manufacturer of that refrigerator. And at the blockchain layer, that's where the actual users and the devices and the service providers are. So this allows for securely updating IoT devices and limiting access to those devices. So a little recap, we talked about a short background on blockchain and its typical uses, and then three security applications of blockchain: the NOR security ecosystem, the secure storage and medical service framework, and the IoT chain. Thank you so much. If you have any questions, feel free to email me. I can forward you this information. And it was a little too quick to be able to talk in detail about some of those systems, but if you have any questions, please email. And here are my references. Thank you.